For the ones who get it done, the most important part is the one you need now. And the best partner is the one who can deliver. That's why millions of maintenance and repair pros trust Grainger, because we have professional-grade supplies for every industry, even hard-to-find products. And we have same-day pickup and next-day delivery on most orders. But most importantly, we have an unwavering commitment to help keep you up and running. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 20 for episode 103, for broadcast on the 13th of September 2021. Coming up on SpaceTime, first evidence for a new type of supernova, new support for the Lambda Cold Dark Matter hypothesis, and Virgin Galactic grounded by the FAA. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have gathered evidence for what appears to be a new type of supernova. Supernovae mark the spectacular explosive death of a star in a blast so powerful it can briefly outshine an entire galaxy. They can occur when a dead stellar core of a sun-like star, known as a white dwarf, draws material off a close companion star until it reaches a point known as the Chandrasekhar limit, which is around 1.44 times the mass of our Sun. This Chandrasekhar limit is a barrier for something known as electron degeneracy. This is the quantum mechanical effect arising from the Pauli exclusion principle that prevents more than one fermion, which is a subatomic particle such as an electron, from being in the same minimum energy level quantum state at the same time. When a white dwarf exceeds this Chandrasekhar limit, it triggers a thermonuclear supernova explosion which will destroy the progenitor star. If a white dwarf close to this limit gravitationally drags additional material onto its surface to the point where it exceeds this Chandrasekhar limit, it can trigger a massive thermonuclear supernova explosion, destroying the white dwarf. A supernova can also occur when a star far more massive than the Sun runs out of fuel for core nuclear fusion. Now this causes the delicate balancing act between nuclear energy pushing outwards from the star's core and gravity crashing down towards its centre from continuing, and gravity wins, causing the stellar core to collapse inwards and triggering a shock wave causing what's called a core collapse supernova explosion. Now these stars have so much mass that their immense gravitational collapse is able to punch through the electron degeneracy barrier of the Chandrasekhar limit, crushing the core's negatively charged electrons and positively charged protons together to form neutrons, in other words, creating a neutron star. Now, if the progenitor star is big enough, instead of forming a neutron star, it'll collapse down even further, creating a black hole, an area of infinite density and zero volume where gravitational forces are so strong, nothing, not even light, can escape. Because most stars are born in close binary systems, a neutron star in such a system can end up spiraling into a close companion star, and that would trigger another core collapse supernova. But such an event has not previously been seen, at least not until now. Astronomers using data from the Very Large Array Sky Survey have detected a new very luminous radio source, catalogued as VTJ 121001 plus 495 9647. This object wasn't present in earlier radio surveys. And follow-up radio and optical spectroscopy showed that the radio source is consistent with an expanding supernova remnant which is interacting with surrounding material which appears to have been ejected from the same star a few centuries before its explosion. The authors are associating this source with an unidentified X-ray transient, which occurred at the same location back in 2014, and that suggests the explosion produced a relativistic jet. A report in the journal Science says this combination of properties is consistent with predictions for a merger-triggered supernova, the first ever detected. This is SpaceTime. Still to come. Astronomers detect the longest intergalactic cosmic filament ever seen, which they say is strong support for the Lambda Cold Dark Matter hypothesis. And the European Space Agency sets a new record with the detection of their millionth near-Earth object. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Astronomers have discovered the longest intergalactic cosmic filament ever seen. The discovery strongly supports what's known as the Lambda Cold Dark Matter model, which is one of the most popular hypotheses to explain the evolution of the universe over the past 13.82 billion years since the Big Bang. This stream of gas is massive, some 50 million light-years long. A report in the journal Astronomy and Astrophysics says it was detected in a system of 3 galaxy clusters known as Abell 339195, which is located some 700 million light-years away. The findings further support earlier observations showing that these gossamer-thin threads of gas contain most of the universe's missing normal baryonic matter. These filaments weave their way through the galaxies, galaxy clusters, and superclusters that surround vast voids, and combine to make up the large-scale cosmic web-like structure of the universe. One of the big problems astronomers have is that so much of the universe is missing. A mysterious force called dark energy is causing the universe's rate of expansion to accelerate. And while scientists know that mass causes gravity, they have no idea what causes this vacuum energy, this dark energy, which seems to act opposite to gravity. But they know there's a lot of it there, because it makes up about 69% of the universe's total matter energy budget. Meanwhile, an invisible substance called dark matter makes up another 27%. Scientists have no idea what that is either, but they can see its gravitational influence on normal so-called baryonic matter. That's the stuff that stars, planets, houses, people, trees, dogs, cats and cars are made out of. Astronomers can see dark matter holding galaxies together, stopping them from flinging apart as they rotate. Now, all that means that only about 4% of the total matter energy budget of the universe can be accounted for. But even this tiny amount of so-called normal or baryonic matter comes with questions. That's because about half of what scientists calculate should be there can actually be accounted for. But over the last few years, there's been more and more evidence that the missing baryonic matter is contained in these gossamer-thin gas filaments threading between galaxies, galaxy clusters and superclusters which surround the vast voids of the large-scale cosmic web-like structure of the universe. Importantly, this latest discovery is strikingly similar to the predictions generated by computer simulations. It supports the idea that the universe expanded out from a Big Bang evenly in all directions, with its matter almost uniformly distributed. Almost uniformly, but not completely. There were some areas which were slightly denser than others, and these generated slightly more gravity, which over time, often millions to billions of years, attracted more and more matter, eventually forming the stars and galaxies we see today. At the same time, the space between them became emptier and emptier, eventually forming the voids. The end result is the large-scale cosmic web. One of the study's authors, Thomas Reiprich from the University of Bonn, says the gossamer-thin gas filaments connecting the galaxies and clusters is the evidence supporting the Lambda Cold Dark Matter hypothesis. He says this gas has escaped detection so far because the enormous expansion of the filaments has diluted the matter in them. In fact, it contains just 10 particles per cubic metre, which is much less than the best vacuum we can create on Earth. The observations were made using Germany's Rosetta Space Telescope. It's equipped with detectors sensitive to the type of X-ray radiation that's emitted by the gas in these filaments. It also has a large field of view, very much like a wide-angle lens, and that allows it to capture a relatively large portion of the sky in a single measurement, and all with relatively high resolution. Meanwhile, astronomers using the CSIRO's ASCAP, Australian Square Kilometre Array Pathfinder radio telescope, provided additional data to their Rosetta team. Professor Ray Norris from the University of Western Sydney says the ASCAP observations complement their Rosetta data to reveal a striking richness of structure and activity in the merging cluster system.
Our understanding of the universe is that after the Big Bang, all the hydrogen gas that was formed after the Big Bang collected into clumps, and these clumps pulled together by their own gravitational forces. And over time, forms a web-like structure, which is called the cosmic web. So what we expect in these models is that all the galaxies we see should be strung along filaments and sheets with great voids in between. So that's what our theory tells us. That's based on our understanding of dark matter and dark energy and so on. And when we look at the galaxies, indeed we see these shapes, it looks like a cosmic web. We've never actually detected the gas in the filaments which we expect. So what we found in this new result that we've published is we've actually detected these hot gas filaments joining the galaxies. And so this is another step in confirming that basic model with dark matter and dark energy is correct.
And not only does it help to confirm that, it also explains where all the missing baryonic matter is, because this has been one of the big puzzles, not just the missing dark matter that's very trendy to talk about, or what the dark matter even is, but the big head scratch has been, well, where's all the normal matter? A lot of it's missing.
That's absolutely right. So when we count up all the matter we see in stars and galaxies, there's still not enough of it. We still expect to see more. And what we've discovered in this filament is that all this mass of hot gas strung out between the galaxies, which very nicely explains the missing matter.
How is this research carried out? This was a huge international collaboration led by the University of Bonn.
Yeah, it's really interesting. So right now, there are these two big new instruments which are both surveying the sky. And one of them, eRosetta, which is built by the Germans, is looking at X-rays. And the other one, ASCAP, built by Australia, is looking in radio waves. So we're both doing a very similar thing, but very different wavelengths. And in this collaboration, we've come together because we realize we actually look at very similar things. And so collaboration is obvious. And so in this result, we've actually used both telescopes, eRosetta and ASCAP, to survey large areas of the sky and look around this cluster and see what we see. So eRosetta actually detected the bridge. They detected the hot gas. We didn't see it with ASCAP, and that's interesting. That tells you, because we expected to see it with ASCAP, and we expected to see all the electrons whipped up by turbulence in this gas, and we would see the radio emission for these electrons, and we don't. So that tells you that the electrons are not being whipped up by turbulence. It's quite smooth. And what we do see in the radio, we see galaxies along the filaments, and those galaxies are falling down into the clusters. Clusters are where the filaments join each other. And the galaxies just appear to be falling down smoothly and not being buffeted by turbulence.
When we talk about something that's 700 million light years away, we think of that as being a long way away, but I guess on the cosmic scale of things, it's not.
That's right. Yeah. So we look at things further away. That's right. So, and of course, as we look further away, we go back in time, because if we look at something, let's say, 10 billion light years away, that means it's taken the light or radio waves from that object. It's taken it 10 billion years to travel from that object to us, to our telescopes. And so we're actually seeing it as it was 10 billion years ago when the light or radio was left it. So when we look out further and further in the universe, we're also looking back in time when you see the very early universe. And so it's really good for this sort of stuff, because we can see we can see the clusters like this one, we can see how they're joined. And we go further back in time by looking at objects further away, and we can see the proto-clusters, when the clusters are first forming, when the cosmic web is first pulling together. And so we can see all the stages of the formation of the cosmic web.
It's a bit like trying to see the forest for all the trees. Is it a difficult job to be able to place ourselves in the universe on that scale?
Well, you're right about the forest and the trees. I mean, one of the problems is that we've had these fantastic telescopes in the past which are able to see exquisite detail in these things. But what we really need to see these clusters is we need telescopes that can see large areas. And this is what both eROSITA and ASCAP do. They're really good at looking at large areas of sky. So our ASCAP radio telescope, it can see as deep into the universe as any other telescope. But its real magic is it can see large areas at once. And so we are seeing things that people have never seen before, just because they haven't been able to stand back. We've been studying the trees, we're able to see the patterns in the forest as well.
With these new observations, does that put an end to MOND, modified Newtonian? Or shouldn't we go there?
Some of us would say that MOND was dead a long time ago, but that's a really good question. So we've known for a while that models of dark matter have problems. So we know there's mass there that we don't see. We see stars going around in galaxies, we see galaxies going around in clusters, and it's as if there's a whole load of missing mass there, which we call dark matter. Now, MOND is an idea that maybe there's no dark matter. Maybe it's just that MOND stands for modified Newtonian dynamics. Maybe our laws of gravity are slightly wrong. And it's a good idea. But the trouble is, MOND, it attacks problems piecemeal. It doesn't actually give you an alternative theory. And it doesn't predict stuff that we're seeing. So, for example, this discovery of the cosmic web, the filament we've now found, that's totally predicted by our idea of dark matter. It is not predicted by MOND. So I wouldn't say this is what cures MOND stone dead. I would say MOND has been comatose for a while. And the prognosis is not good.
That's Professor Ray Norris from the University of Western Sydney. And this is SpaceTime. Still to come, more than 1 million near-Earth objects detected and Virgin Galactic grounded by the FAA. All that and more still to come on SpaceTime. The European Space Agency's Planetary Defence Office catalogue of asteroids with good orbital information has now surpassed 1 million. In fact, August alone saw the discovery of 294 near-Earth objects. That brings the total number of NEOs discovered this year to 1,714. Overall, the million milestone figure includes 26,498 near-Earth asteroids and 115 comets. Now, these are objects whose orbits bring them close to or across the Earth's orbit around the Sun. And of those 26,500 objects, 1,190 are considered to be on the high-risk list. The most notable on the latest list is 2021 QM1. It's a moderately large 50-metre wide object with multiple possible impacts with Earth over the next century. But the good news is possible doesn't mean very likely, because the total impact probability is only about 1 in 15,000. So, I guess you can afford to sleep comfortably tonight. This is SpaceTime. Still to come, Virgin Galactic grounded by the FAA, and later in the science report, a grim picture for Australia's most endangered plants and animals. All that and more still to come on SpaceTime. The United States Federal Aviation Administration, the FAA, has grounded Virgin Galactic as it investigates why its last flight to the edge of space deviated from its planned trajectory. The July 11th flight by the Spaceship Two Unity carried Virgin Galactic boss Richard Branson to an altitude of 86 kilometres. The FAA says it's keeping a close eye on Virgin Galactic's own investigation of the mishap, which occurred during the ascent over Spaceport America in New Mexico. The report suggests that Unity's climb was too shallow, with the nose insufficiently vertical. Now, Virgin Galactic says Unity did encounter high-altitude winds and they changed its trajectory, but overall the flight remained within mission parameters, achieving Mach 3 and an altitude of 86 kilometers before safely returning to the Earth. It's unclear whether Unity's next flight, which will carry members of the Italian Air Force, will still take place as scheduled late this month or early next. Virgin Galactic reopened ticket sales last month, selling trips to the edge of space at $450,000 a seat. And that's a sharp increase on the $250,000 ticket price they were charging previously. The company says that so far around 600 people have booked seats. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that the Delta variant of the COVID-19 coronavirus is 8 times less sensitive to the antibodies generated by vaccination with Pfizer or AstraZeneca compared to the original China Wuhan virus strain. The findings, reported in the journal Nature, also found that the Delta variant was more efficient at replicating than the Alpha variant, and was able to replicate and enter cells better than the Kappa variant, thanks largely to changes in the Delta spike protein. The authors say this may explain the dominance of Delta. The research also found that the AstraZeneca vaccine was less effective against the Delta variant than other variants, prompting the authors to conclude that we need strategies to boost vaccine responses against variants. Meanwhile, a separate report, this one in the New England Journal of Medicine, claims the Pfizer, Moderna and AstraZeneca vaccines are still all highly effective against severe COVID-19, requiring emergency department, hospitalization, or intensive care unit admission. The study looked at more than 60,000 emergency department visits or hospital admissions. It then estimated vaccine effectiveness by comparing the odds of a positive test for SARS-CoV-2 infection among vaccinated patients with those among unvaccinated patients. They found the Pfizer and Moderna mRNA vaccines were 91% effective against COVID-19 infection leading to an emergency department visit, while the AstraZeneca vaccine was 73% effective. The effectiveness was similar in at-risk populations, such as those over 85 and those with chronic medical conditions. The World Health Organization says that more than 8 million people have been killed by the COVID-19 coronavirus, with well over 4.6 million confirmed fatalities and in excess of 230 million infected people. The first comprehensive list of the threats posed to Australia's most endangered plants and animals reveals a grim picture about the future of some of the country's most loved natives. The findings, reported in the journal Ecology and Evolution, includes an in-depth analysis of almost 1,800 plants and animals listed as threatened under Australian Commonwealth law, including 1,339 plants and 456 animals. The University of Queensland-led study has compiled a dataset listing the threats to Australian species from habitat loss, fragmentation and degradation. Among its many findings, the swift parrot is facing 17 different threats, including habitat loss from logging and agriculture, invasive weeds, and the many and varying effects of climate change. Similarly, koalas are facing 9 threats, including habitat loss from agriculture and urban development, dog attack, and disease. The findings have been provided to the federal and state governments, as well as conservation groups including BirdLife Australia, the Worldwide Fund for Nature, and the Nature Conservancy. A new study claims that bisexuals have more than twice the rates of asthma and lung diseases compared to straight people. The findings, reported in the Annals of the American Thoracic Society, are based on a survey of 12,209 adults enrolled in the American National Longitudinal Study of Adolescent to Adult Health. The authors found that 29% of bisexual adults reported experiencing lung disease, compared to just 14% of heterosexuals. Researchers think higher levels of discrimination experienced by bisexual people could be leading to more stress and inflammation or stress hormones, which would worsen any asthma condition. Bisexual adults have already been shown to have worse health outcomes across a number of physical and mental health domains. On the streets of Manhattan, Tuesday, September the 11th, 2001, was a beautiful, sparkling, clear blue summer morning. Millions of New Yorkers were going about their business as they did every day. Kids going to school, people shopping, others going to work. The streets were packed, traffic was at a crawl, as it always is, and the subways were crowded with commuters from New Jersey, Long Island and beyond. However, all that suddenly changed at 8:46 a.m. as American Airlines Flight 11 roared thunderously overhead and then, shockingly, crashed full throttle into the North Tower of the World Trade Center in Lower Manhattan. The impact created a scene from hell. Burning bodies and debris rained down onto the streets. Black, billowing smoke climbed high into the sky, and everywhere the smell of jet fuel filled the air. At first it all seemed like a horrible accident, but then 17 minutes later at 9:03 a.m, a second aircraft, United Airlines Flight 175, suddenly slammed into the World Trade Center's South Tower, and it was clear that America was under attack. Both the iconic 110-story towers collapsed within an hour and 42 minutes. And surrounding buildings, including 7 World Trade Center, were also significantly damaged or destroyed. The two airlines had been hijacked by Islamic terrorists, part of a radical group called Al-Qaeda or the Base. As the world was coming to terms with what had just happened in Manhattan, at 9:37 a.m, a third hijacked plane, American Airlines Flight 77, crashed into the west side of the Pentagon in Arlington, Virginia, causing a partial collapse. A fourth and final hijacked aircraft, United Airlines Flight 93, was also flying in the direction of Washington, D.C., heading for either the White House or the U.S. Capitol building. But by this time the plane's passengers, aware of what was happening in New York and Washington, attempted to regain control of the aircraft from the hijackers, ultimately succeeding in diverting the plane from its intended target, sacrificing their own lives by forcing the plane to crash into an empty field near Shanksville, Pennsylvania at 10:03 a.m. It was America's first strike back against the terrorism on this terrible day. In all, some 3,000 innocent men, women and children were killed in the attacks. A further 25,000 were injured. And another 3,000, mostly first responders, would die later from the toxic pollution generated by the attacks. Despite all the eyewitness accounts, all the forensic evidence, and even the recorded admissions of guilt by Al-Qaeda boss Osama bin Laden, there are still conspiracy theorists out there who refuse to accept the evidence. Tim Mendham from Australian Skeptics says the facts are clear.
It was an act of Islamic terrorism. All the evidence, what it comes down to is the idea, were the buildings generally blown up on purpose rather than planes flying into them, although there were planes flying into them. It was seen from multiple angles by multiple people. But was it actually purposely blown up to create an environment in which the American government could effectively wage war on other countries, etc., as a revenge or whatever? But all the evidence points to that it was people flying planes with normal fuel load into the buildings, into the Pentagon, and ultra effective on the Twin Towers, not that effective on the Pentagon. And the plane that crashed in Pennsylvania was thanks to the passengers. The scientific evidence, and it's been covered by many places. Best place to go is Popular Mechanics, which did a thorough, and has done thorough investigations for years and years, and they put out a book and it's regularly updated and that sort of stuff. The theories, the conspiracy theories are not that well updated, but they keep recycling the same ones over and over again. The classic one is that the fire from burning fuel is not hot enough to melt steel, so why did the building collapse? Because it doesn't need to be hot enough to melt steel, it just needs to be hot enough to bend the steel, soften it, and then the gravity, the weight of the building takes over from there. And all sorts of theories Popular Mechanics is the best place to go to see a thorough, detailed, and you can just do Popular Mechanics 9/11 and you'll find it. Yeah, skeptics' point of view, it was a real terrorist action. As far as we know, there's no government involvement. There doesn't need to be. The physical aspects of the planes crashing into the buildings was enough to cause the destruction. And, and you can go into all the scientific details you want to go into. So it's one of those ones that is just a perennial, whether it's moon landing, whether it's Kennedy assassination. They have a longevity far beyond their worth. And really, sort of, why bother? And it's a sad situation, I think, when people that have just refused to listen and refused to hear independent judgments, and not by governments, but by other people. So, act of terrorism, unfortunately, and everything else followed the engineering principles.
What does it say about the people who keep pushing these conspiracy lines? Are these people who are so inferior in their own minds that they need to give the impression that they have special knowledge that no one else has? Special knowledge that no one else has that they share with everybody. Well, yes.
It is a strange thing. That's the $64 question. Why are conspiracy theorists, conspiracists? Why do they believe such things? There's a multitude of reasons. One is obviously personal. Obviously, you talk about people who are unhappy in their lives, etc. They've been put upon. They've had bad luck. They feel like people are acting against them, and that helps create the environment in which everything is someone hurting them rather than their own actions or just bad luck. And other things is sort of, mistrust of governments. Some people are in it for the notoriety. Obviously, some of the leaders are there. They enjoy the fame and the fortune, whatever. Some people just like stirring. Some people are paranoid. And there's a multitude of reasons. We've actually discussed this in our magazine, The Skeptic, about why are people creationists, why are people UFO fanatics, why are people 9/11. The interesting thing about 9/11 is they claim to be scientifically based. So they're not doubting science. They're just doubting real science. And so therefore, they're trying to place themselves in the reasonable category, but their results are not reasonable. Or they lack reason. So, why are they like that?
Well, that's the Dunning-Kruger effect coming in there, isn't it?
It's definitely coming in there a bit, I think. But, there are intelligent people out there. There are unintelligent people. There are educated people. There are uneducated people amongst the believers in these things. They run the gamut, as society does. But there's obviously something they have in common is a sense of disbelief and paranoia.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.